Welcome back. Now let us solve Numerical Paper 2. These are simpler problems and we will work each one from the basics so the ideas really stick. Remember our golden rule. A load equals the area of its shape and it acts through the centroid of that shape. Let us begin. Problem 1. A cantilever fixed at one end, 2 meters long, carrying a uniformly distributed load of 1 kilonewton per meter. To handle a spread out load, we replace it with a single equivalent point load. The shape of a UDL is a rectangle. Its total is the area, intensity times length, 1 times 2, which is 2 kilonewtons, and it acts at the center of the rectangle at the middle of the loaded length, 1 meter from the fixed end. Problem 2. A 5-meter beam with a UDL of 10 kilonewtons per meter. The equivalent load is the area of the rectangle 10 times 5, 50 kilonewtons, acting at mid-span 2.5 meters from A. And since the load is symmetric about the middle, the two supports share it equally. Each reaction is half of 50, so RA and RB are both 25 kilonewtons. Problem 3. A 6-meter beam with a triangular load 0 at A rising to 9 kilonewtons per meter at B. The load shape is a triangle, so its area is half of base times height, half of 9 times 6, which is 27 kilonewtons. The resultant acts through the centroid 1/3 from the tall end B, that is 2 meters from B or 4 meters from A. Problem 4. An 8-meter beam with a UDL of 6 kilonewtons per meter, same rectangle rule. The equivalent load is 6 times 8, 48 kilonewtons, at midspan 4 meters from A symmetric, so each support carries half. RA and RB are both 24 kilonewtons. Problem 5. AUDL of 20 kilonewtons per meter over a 2-meter part of the beam, only the loaded length counts. So the equivalent load is 20 times 2, 40 kilonewtons, acting at the middle of that loaded part, 1 meter from where it starts. Problem 6. A 4-meter beam with a single 40 kilonewton load right at its center. Because the load sits exactly at mid-span, the situation is perfectly symmetric. So both supports carry an equal share, half of 40. RA and RB are both 20 kilonewtons. Problem 7. A 4-meter beam, two 10 kilonewton loads, each 1 meter from a support. The total is 20 kilonewtons and they are placed symmetrically about the middle. So the supports share equally and each reaction is half of 20, 10 kilonewtons. Problem 8. A couple two equal and opposite forces of 15 kilonewtons, 0.6 meters apart. A couple produces a pure turning effect and its moment is the force times the perpendicular distance. M equals 15 times 0.6, which is 9 kilonewton meters. Problem 9. Two forces of 20 kilonewtons equal and opposite, 0.5 meters apart. Because they are equal and opposite, they cancel. So the resultant force is 0, but the couple remains. Its moment is 20 times 0.5, which is 10 kilonewton meters. Problem 10. A reverse problem. A triangular load over 6 meters has an equivalent load of 30 kilonewtons. We want the maximum intensity W. For a triangle, P equals half WL. Rearranging W equals 2P over L, that is 2 times 30 over 6, 60 over 6, which is 10 kilonewtons per meter. And that completes paper 2 and our full practice on the types of loads. Every single problem came down to two ideas. A load equals the area of its shape and it acts through the centroid. Score yourself out of 50, 42 and above is excellent, 32 to 41 is good. Below 32, revise once more. Next in beam statics, we will find the support reactions properly. For more MCQ practice, join our Telegram channel, subscribe and hit the bell. Keep it simple, keep it civil.